Go ahead and split your notebook into 6 sections with a title, Degree Radian Conversion. Hello everyone, welcome to our series of pre-calculus review. Today is a quick video on degree in radian conversion. So let's start by defining what a radian is. A radian is an angle, and specifically, it's the angle measure created from the arc of one radius. So if I were to draw a circle, we all should know what a radius is, or if we can recall from geometry, the radius is the distance from the center to anywhere on the circumference of the circle. So this distance here is one radius, okay? And in order to create a radian, I would need to take this measurement and measure it on the circumference to create an arc. And this angle that's created in here is one radian, okay? So let me show you with numbers. Let's say, for example, I have a circle and the radius is 2 inches. Then I would need to measure 2 inches out here. And that would create exactly 1 radian. The angle inside is 1 radian. And if you recall from pre-calculus, there are exactly 4, 5, 6 radian, 2, 3, 4, 5, 6 radians, and a little bit extra. Approximately 6.28 radians. And 6.28 radians, if I wanted to be more exact, is equal to 2 pi. So there are exactly 2 pi radians in one circle. So we could say that 2 pi radians is the same as 360 degrees. Okay? So now that we know that 2 pi radians is equal to 360 degrees, I can create a conversion. So if I were to, for example, divide 2 pi radians by 2 pi, I would get that 1 radian. That is equal to about 57.29 degrees. Okay. Now, what I like to use for conversions is a simple fraction. So I take 2 pi radians equal to 380 degrees, 360 degrees, and I divide both sides by 2. Okay. And that tells me that pi radians is the same as 180 degrees. So these two are equal to each other, meaning that I can use a fraction of 180 degrees over pi radians, or pi radians over 180 degrees to convert between degrees and radians. So when converting from radians to degrees, if I have radians on the top and degrees on the bottom, and I want to convert 2 degrees, I would need to multiply by 180 degrees over pi. And vice versa, if I have radians and I want to get 2 degrees, this is written the same. Oops. This should be from degrees to radians. Typo. I would need to multiply by the opposite. So I would need to multiply by pi over 180 degrees in order to convert from degrees and radians. So let's do some practice. It says convert 210 to radians. So here I'm going from degrees to radians. And according to my notes we just took, in order to get from degrees to radians, I would need to use this equation, okay? So I'm going to take my 210 and I'm going to multiply by pi radians over 180 degrees. Okay. Now if I do this, I'm going to go ahead and multiply across here. I'm going to get 210 times pi over 180. And what's cool is that because I have degrees on the top and degrees on the bottom, my degree sign cancels and I'm left with radians. So I now have radians. However, I need to simplify. So 210 and 180 can both be divided by 30. So I'm going to go ahead and divide by 30 on the top and the bottom. 210 divided by 30 is going to give me 7 pi. And 180 divided by 30 gives me 6. So my total radians is 7 pi over 6. So 210 degrees is the same as 7 pi over 6. Okay. Now let's go ahead and convert 45 degrees to radians. So same thing, I take my 45 degrees. I'm going to multiply by pi radians over 180. And the degree sign is going to cancel. And I'm going to be left with radians. Right? And now we multiply across. And I have 45 pi over 180. Now, some of you guys might be better at simplifying than others. You might want to simplify by 5, simplify by 9. But regardless of how you simplify, I'm going to simplify by 45. You're going to end up with pi over 4 radians. Okay. Now let's practice the other way around. I'm going to go from radians to degrees. And when I'm multiplying radians to degrees or converting, I need to use the opposite fraction of 180 over pi. Okay? So, in this case, take my pi over 3 radians. And I'm going to multiply by, we said, 180 degrees over pi radians. Same thing happens here. The radians on the top and radians on the bottom are gone. And I'm left with degrees, so I know my answer is going to be in degrees. And what else is the same on the top and the bottom? I have a pi on the top and a pi on the bottom. So I'm left with 180 on the top and 3 on the bottom. So 180 divided by 3, if I simplify this, is 60 degrees. So I know that pi over 3 is the same as 60 degrees. Okay, 7 pi over 4. Same thing, I'm going to take my 7 pi radians over 4, and I'm multiplying by 180 degrees over pi radians. Let's see what's the same on the top and the bottom. Radians that are the same on the top and the bottom. Pi also gets divided out. And so I'm left with 7 times 180 over 4. And I know that 7 times 180 is 1,260. And I need to divide this by 4. And if I divide that by 4, I get 315. And remember, my units that I was left over with are degrees. So my answer is 315 degrees. Okay. Now, I'm going to convert the following angles to degrees. These are in radians. Okay. And I'm going to show you a different way that you can convert these to degrees, which is my favorite way to do it. So you could still do the 180 over pi, right? Or we learned that pi is the same as 180. And I'm going to go back into our notes here. Right here. We learned that pi is equal to 180, okay? So pi is equal to 180. So if I know this idea, again, that pi is equal to 180, then this pi, I'm going to just change to a 180. And now I'm left with 180 divided by 6 is 30. Do you guys see what I did there? Same thing on this problem. My pi, I'm going to convert to be 180. Everything else is going to stay the same. So the pi became 180. And now I just multiply. I'm going to get 720. And if I divide that by 3, I get 240 degrees. Hopefully you all enjoyed this video on degree and radian conversion. Next, we're going to be talking about angles and their measure.